Long before the first pharaoh raised his crown, before the Nile had found its present path, a different world stood beneath the same sky. The Giza Plateau, silent, mathematical, eternal, may not be the beginning of civilization, but the remnant of one that came before. Beneath its sand lies the trace of rainfall on stone, the signature of lost builders, and equations too perfect for chance. In this journey, we will descend through layers of time, past dynasties and legends, into an age erased from memory. The monuments of Egypt do not speak in words, but in proportion and alignment, hinting at a forgotten science and a flood that nearly ended it all. Tonight, we listen not for stories told by history, but for the quiet evidence it buried. This is Giza's hidden timeline, the proof of a world that time tried to erase. The sand beneath the foundation, beneath the Giza Plateau, lies a silence that has lasted longer than the pyramids themselves. The desert surface, shaped by time and buried wind, hides a second landscape, one of older stone and forgotten lines. When early explorers arrived in the 19th century, men like Flinders Petrie and Carl Richard Lepsius noticed that the bedrock had been cut, not merely dug. Smooth, precise troughs traced through limestone, as though carved by tools unknown to the dynasties that followed. These grooves, lying under the Great Pyramid's base, hinted that Giza's builders may have inherited the site rather than founded it. In 1993, geological engineer Robert Schoch stood at the Sphinx's enclosure wall. He saw what archaeologists had dismissed for decades: the strange vertical undulations of the limestone, curving and weathered like the face of a canyon. According to him, this was not wind erosion, but rainfall erosion. If he was right, the stone was carved during a period when heavy rains still fell on the plateau between 7000 and 9000 BCE, long before the reign of Khafre, who officially commissioned the Sphinx around 2500 BCE. The discovery quietly divided the academic world. Egyptologists rejected it as impossible. Geologists, observing the data, called it likely. Later, in 1997, Thomas Debicki joined Schoch for further measurements. They used seismic readings to estimate the depth of weathering beneath the Sphinx's enclosure. The results again suggested thousands of years of exposure to moisture far older than the accepted timeline of Old Kingdom Egypt. The surrounding strata, they noted, were uneven. Certain blocks beneath the monument's pores appeared to rest on even older foundations, as if the statue was a restoration, not a creation. At the same time, French engineer André Pochin revisited Petrie's survey data from the Great Pyramid. Beneath its outer casing and basalt pavement, he identified a peculiar pattern in the foundation: cuts irregular, deep, and sometimes curved. They did not match the precision of Fourth Dynasty planning. Some sections appeared melted, as if softened by intense heat or chemical reaction. Samples taken from fragments near the southern base later showed traces of silicate fusion, something not expected from simple limestone erosion. The implication was unsettling. The pyramid stood on an earlier surface altered by unknown forces, perhaps geological, perhaps man-made. Satellite mapping in the early 2000s added another layer. Infrared imagery from the University of Boston's archaeology program revealed linear anomalies extending beneath the desert east of the Sphinx. These lines aligned with neither tomb shafts nor causeways. They ran deeper, at angles that mirrored the Nile's ancient course before it shifted thousands of years ago. When the data were compared with magnetic surveys, a faint rectangular outline emerged, a possible substructure lying 30 meters below the sand. Egyptian authorities classified the coordinates, citing preservation concerns, but internal reports leaked through European research journals described it as architectural in geometry, sedimentary in context. Local workers had long spoken of tunnels under the Giza Plateau. During restorations in the 1930 seconds, Selim Hassan documented several sealed shafts near the Sphinx temple. One passage, roughly 2 meters wide, descended in steps before being blocked by rubble at a depth of 12 meters. His team reported the sound of echoing space beyond. They noted that the air was cooler than outside, suggesting an open cavity. The notes, preserved in the Cairo Museum archives, mention a possible connection to the Lower Plateau system, older than the dynastic era. No further excavations were authorized. In 2010, a joint team from Cairo University and Waseda University in Tokyo conducted ground-penetrating radar scans between the Sphinx and the Great Pyramid. The data showed several voids of geometric symmetry, one large chamber beneath the Sphinx's left paw, another corridor-like feature extending toward the pyramid's southeast corner. The Egyptian Ministry of Antiquities later referred to these as natural fissures, yet the angles measured precisely 90 degrees apart, inconsistent with natural formation. There are also the water shafts. At the northwest base of the Great Pyramid, a small cavity discovered in 1926 was filled with standing water. When modern researchers reopened it, they found the water level to be constant, year-round, unaffected by rainfall or pumping nearby. Geologists concluded it was fed by an underground aquifer connected to the ancient Nile floodplain. Its presence suggests that the original builders had mapped and perhaps harnessed this water source, a form of hydraulic stabilization unknown to dynastic architects. Ancient texts speak of a Zep Tepi the first time. In the pyramid texts of Saqqara, this era is described as when the gods walked on earth in the primeval land before the flood. For centuries, this was seen as myth. Yet, the geological record supports a flood event around 10,000 BCE, matching the end of the Younger Dryas. The Sphinx's erosion lines fall within the same period. If the monument's body was carved then, its face recarved to resemble Khafre could be much younger. The ancient priests, preserving the myth of Zep Tepi, may have remembered not a creation story, but an inheritance. Archaeologist Mark Lenner, initially a critic of the older Sphinx theory, later found evidence of large-scale restoration dating to the Old Kingdom. The stone blocks, replacing the body's eroded flanks, were fitted with mortar containing crushed pottery fragments from Khafre's reign. That meant the statue was already old enough to require repair during his time. The debate did not end, but it shifted. The question was no longer who built it, but what came before. The plateau itself tells part of the answer. Beneath its sand are remnants of fossilized sea life coral, shells, and marine sediment evidence that this region once lay under the Tethys Sea millions of years ago. The builders, ancient or otherwise, chose limestone formed by vanished oceans to construct monuments aligned with celestial precision. The Great Pyramid's sides deviate less than 1/15 of a degree from true north, a feat unmatched until modern surveying. If the purpose was only tomb construction, such astronomical accuracy remains unexplained. In 1982, engineer Rudolf Gantenbrink designed a robot named Upuat 2 to explore the narrow shafts inside the Great Pyramid's Queen's Chamber. It discovered a small limestone door with copper fittings sealed, never opened since antiquity. Behind it, later imaging revealed a second door. Both were aligned not with the pyramid's internal architecture, but with the stars of Orion's belt, as they appeared around 10,500 BCE. The alignment date mirrors that of the so-called Orion correlation theory, which posits that the three pyramids mirror the star's pattern from that same epoch. Whether coincidence or design, the geometry suggests a preserved memory of a sky thousands of years older than the accepted pyramid age. The deeper researchers dig, the older Giza becomes. Each layer reveals not a beginning but a handover, a sequence of inheritances buried in the same sand. Bedrock carved before dynasties, monuments restored instead of built, foundations older than their kings. The plateau endures as a palimpsest of human and geological time, each stratum marking a forgotten chapter of civilization that may have stood before Egypt itself. The water beneath the stones. Long before the pyramids rose against the desert horizon, water shaped the Giza Plateau. The limestone it stands on was not formed by wind or sand, but by an ancient sea. Traces of marine shells and coral embedded in the stone tell of a time when this land lay beneath the Tethys Ocean more than 40 million years ago. The builders of later ages may not have known its age, but they understood its strength and its quiet secret. Beneath the ground ran channels of moisture, underground rivers trapped between layers of rock. In 1933, French engineer Émile Barrès began restoring the Sphinx. During excavation, his team encountered deep fissures filled with damp sand. Some of them led into chambers where humidity remained stable even during the hottest months. Barrès wrote in his field notes that water seems to live beneath the statue. His findings were never officially published, but later, studies confirmed a network of groundwater veins running under the entire plateau. They rise and fall with the Nile, though separated from it by thick beds of marl and clay. In the 1940 seconds, American geologist Farouk El-Baz studied satellite photographs of Egypt and proposed that ancient engineers may have deliberately positioned their monuments over zones of stable groundwater. The Great Pyramid, when mapped using resistivity methods in 1989, aligned perfectly above one of these aquifers. Its foundation, though massive, shows no sign of uneven sinking, suggesting the builders understood the subsurface behavior of their terrain. Egyptian hydrologists in 1991 conducted a borehole study near the Sphinx. At a depth of 40 meters, they encountered a sudden pocket of cold, clear water. Its mineral composition did not match the surface Nile deposits, but resembled ancient trapped water sealed since prehistoric floods. The discovery remained largely unpublicized, but local records mention sacred wells that never dry, revered since dynastic times. Some researchers connected these findings to older legends. The Greek historian Herodotus, writing in the 5th century BCE, described underground chambers beneath Giza, filled with water from the Nile. He claimed the Great Pyramid had a hidden shaft leading to a small island where a sarcophagus once rested. Later translations dismissed this as myth, yet geological mapping supports the possibility of subsurface cavities. When radar teams from the University of Tokyo scanned beneath the plateau in 2010, they found low-density anomalies that match the description of flooded voids. The Hall of Records, a term popularized by Edgar Cayce in the early 20th century, drew attention to these supposed underground structures. Cayce claimed that somewhere beneath the Sphinx lay an ancient library containing records from a civilization predating Egypt, possibly Atlantean. Though his trance readings were dismissed by science, they inspired decades of exploration. In 1998, a team led by Dr. Joseph Shaw obtained permission to survey the area using ground-penetrating radar. Their data revealed a chamber-like anomaly directly beneath the Sphinx's left paw, measuring approximately 9 by 12 meters. It has never been excavated. The Egyptian government, through the Supreme Council of Antiquities, restricted all digs near that zone after 1999. Zahi Hawass, then Director of Antiquities, stated that no foreign mission would chase after ghosts. Yet Hawass himself had acknowledged earlier, in a 1994 interview, that an uncharted cavity did exist under the monument. There is something there, he said, but it is not what people think. His later silence only deepened the mystery. The plateau's water behavior continues to fascinate modern geologists. Seasonal fluctuations in humidity beneath the Sphinx show rhythmic patterns corresponding to ancient Nile flooding, even though the river has long since shifted eastward. This suggests that older channels still pulse beneath the surface, as if remembering the flow that once passed through them. Some propose that these underground streams may have influenced the siting of the monuments, that the builders sought harmony between heaven's stars and the earth's hidden waters. Ancient Egyptian symbolism supports this dual awareness. In temple inscriptions, the god Osiris is said to dwell in the waters below, representing both fertility and the underworld. Priests believed that sacred knowledge lay submerged beneath the Nile's surface. Texts from the Pyramid Age speak of the Lake of Flowers, a subterranean domain where the gods kept the secrets of rebirth. Whether metaphor or memory, the motif of hidden water persists throughout Egyptian cosmology. Modern researchers, like Dr. Abbas Shukri, have proposed that ancient architects might have used natural aquifers to stabilize their massive structures. Water, when trapped in porous limestone, creates hydrostatic pressure that can balance shifting loads. This would explain why the Great Pyramid's foundation remains intact after 4.5 millennia, while later pyramids, built on drier ground, collapsed. Such engineering knowledge would have required precise mapping of the underground, perhaps inherited from earlier cultures familiar with the plateau long before the Old Kingdom. Artifacts found in nearby quarries deepen the mystery. Tools embedded in ancient sediment layers show wear inconsistent with copper chisels. A polished stone fragment unearthed in 1972 bore marks, resembling modern coring circular grooves cut into diorite. If this belonged to an earlier epoch, it may represent an understanding of stone manipulation unknown to dynastic Egypt. These remnants, lying close to the aquifer veins, suggest human presence during wetter climates, possibly between 8,000 and 5,000 BCE. Local oral traditions support the idea of hidden water structures. Villagers from Nazlet el Saman, living near the Sphinx's shadow, speak of hollow sounds under the ground. During construction in the 1,920 seconds, workers claimed their tools occasionally struck empty rock. Some refused to dig deeper, fearing collapse. The old families still refer to certain fenced-off areas as the sleeping wells. In 2015, microgravity surveys by Scan Pyramids, a collaboration between Cairo University and the Heritage Innovation Preservation Institute, confirmed multiple voids beneath the Great Pyramid, including one large cavity estimated at 30 meters in length. Though labeled a structural anomaly, its precise geometry and alignment suggest intentional design. Some believe these voids could have served as pressure release chambers connected to hydraulic systems used during construction, channeling water to lift blocks through buoyancy rather than ramps. Such a technique aligns with ancient accounts from the inventor Heron of Alexandria, who described early experiments with water pressure in temples to move doors and statues. If even fragments of that knowledge existed thousands of years earlier, it may have been applied on a scale now forgotten. The Giza Plateau, therefore, might not be a dry monument field, but the remnant of an engineered landscape where stone and water work together. The foundations breathe, the chambers sweat, and beneath the sand, faint traces of ancient moisture still move through hidden veins. Each drop marks an older rhythm, perhaps belonging to a world that shaped the land before Egypt knew its name. The architects before the pharaohs. When the desert winds sweep across Giza, they brush against lines too straight, angles too true for mere chance. The plateau's geometry, even when stripped of stone and shadow, holds order, an ancient map drawn into earth. Archaeologists trace it to the 4th dynasty, around 2600 BCE, yet fragments buried beneath suggest a far deeper origin, when the Nile flowed closer to the west and the stars above marked a different age. In 1899, Sir Flinders Petrie measured the base of the Great Pyramid to within fractions of an inch. He noted that the platform's orientation to true north was nearly perfect, deviating by less than 4 arc minutes. For decades, this precision was credited to the genius of Khufu's architects. But when modern astronomers recalculated Earth's axial precession, they discovered that the alignment would have been exact without error if laid out around 10,450 BCE, the same epoch that mirrored the belt of Orion's alignment with the pyramids themselves. The implication was simple yet profound. Whoever first measured the plateau did so when the constellation system above looked entirely different. By Khufu's time, those stars had already drifted out of position. In 1954, Kamal el-Malek uncovered a sealed pit beside the Great Pyramid's southern face. Inside rested the disassembled timbers of a 140-foot cedar vessel, the Khufu ship. Its craftsmanship astonished restorers. No metal nails, only precisely fitted joints bound by rope and resin. The cedar came from Lebanon, hundreds of kilometers away. Yet some beams showed signs of reuse, their surfaces darkened by earlier weathering. Carbon dating later suggested the wood predated Khufu's reign by centuries. It was as if the pharaoh had inherited materials already ancient, incorporating fragments from a forgotten age into his own monuments. Further east, beneath the sand near Abu Rawash, French archaeologists found remains of a truncated pyramid, its base eroded into irregular layers. Unlike later pyramids, its foundation stones were enormous, each weighing up to 60 tons. Tool marks suggested cutting with a technique more advanced than simple pounding or chiseling. Petrological analysis showed traces of high-temperature vitrification on some blocks, as if fused under extreme heat. The site was abandoned early, perhaps because its builders were not Khufu's men, but earlier engineers whose methods were later lost. In 1994, researcher John Anthony West revisited the plateau's layout. Using aerial photogrammetry, he overlaid the pyramid's geometry with celestial charts. The alignments extended beyond Orion. The causeways pointed toward Sirius and Leo, two symbols revered since the earliest myths of Egypt's first time. At the same epoch of 10,500 BCE, these stars would have risen precisely where the Sphinx faced the dawn. The monuments seemed to encode a sky long vanished, as though remembering an ancestral night. Near the base of the Great Pyramid, small stone cuttings form what Petrie called trial passages, practice tunnels, exact in angle and proportion to the pyramid's internal shafts. They serve no structural function, suggesting that builders rehearsed their alignments before constructing the main passages. But the bedrock around them shows signs of weathering older than the pyramid itself. This raises the possibility that the trial passages were not rehearsals, but remnants templates left by earlier surveyors long before the pyramid rose. In 2005, satellite imagery from the European Space Agency's radar satellites detected faint rectilinear features northwest of Giza. These appeared as geometric anomalies, their orientation nearly parallel to the pyramid's baselines. They may represent foundations of earlier structures now buried. Egyptian authorities marked the coordinates, but have not excavated them. The shapes, visible only in radar spectra, resemble temple layouts seen in pre-dynastic sites along the Nile Delta, suggesting continuity between unknown early cultures and the later pharaonic system. Stone tool evidence also challenges the accepted timeline. Artifacts found in the Mokattam quarries where pyramid limestone was extracted show smoother cutting than copper chisels allow. Experimental archaeology has failed to reproduce these surfaces using tools of the known dynastic period. Under magnification, grooves appear uniform and parallel, as if made by machines using rotary motion. Though this claim remains controversial, it implies knowledge of stoneworking techniques not rediscovered until modern times. One fragment, catalogued in 1932 and later re-examined by engineer Christopher Dunn, bore microscopic traces of abrasion similar to those produced by ultrasonic vibration. Dunn proposed that the ancient builders may have used mechanical resonance to cut or polish hard stone. The idea remains unproven, but the fragment stored quietly in the Cairo Museum's basement still carries grooves as clean as those made by industrial drills. The architectural precision at Giza continues underground. Subterranean chambers beneath the Great Pyramid, carved directly into bedrock, show symmetrical cornering and level floors within millimeters of accuracy. No hieroglyphs mark these halls, no evidence links them to funerary rites. Some scholars believe they predate the pyramid itself, possibly serving as survey anchors for an earlier structure. When water seeps into these chambers during the Nile's flood season, it follows perfectly engineered drains proof of an understanding of both hydraulics and stone behavior over time. The layout of Giza's monuments forms not just an architectural plan, but an astronomical diagram. The spacing between the three main pyramids reflects the angular separation of Orion's belt as viewed from Earth. The Sphinx's gaze meets the rising point of Leo during the vernal equinox, yet this occurred not in 2500 BCE, but around 10,500 BCE. For the builders to encode that alignment, they must have calculated celestial precession, something officially discovered only by Greek astronomer Hipparchus in the 2nd century BCE. Hieroglyphic texts from later periods speak of a house of Thoth, the god of measurement, who set the stars in their places. Thoth's symbol, a crescent and stylus, appears carved into early dynastic palettes found near Abydos, but the concept of cosmic order, Ma'at, may trace back to an older intellectual tradition preserved by the pyramid architects. They were not merely builders, but astronomers, surveyors, and geometers. Their science inherited rather than invented. Modern mapping by Glenn Dash and Mark Lenner in 2015 confirmed that the pyramid's foundations form a single integrated plan, oriented not to the local horizon, but to the true cardinal points, calculated by stellar transit. The precision required multiple observations across centuries or inherited charts from an age when the stars held different positions. Such continuity suggests that the architects before the pharaohs recorded their work in a form beyond stone knowledge, passed silently across generations until Khufu's builders acted upon it. Across the desert, time buried the memory of those who measured first. Their lines remain under layers of history, drawn through both earth and sky. What remains above the pyramids, the Sphinx, the causeways, may be only the last echoes of an older plan, conceived by hands that watched a different heaven and traced it faithfully onto the ground. The forgotten blueprints. Across the golden plain of Giza, every stone seems placed with quiet purpose. When measured closely, patterns emerge, ratios, alignments, and geometric constants that repeat not by accident, but by design. Scholars of the 19th century saw in the pyramids mere monuments of burial. Later generations found mathematics instead numbers so deliberate that they appear to encode principles known only to much later civilizations. In 1859, British researcher John Taylor published The Great Pyramid. Why was it built? He noted that the pyramid's height, when compared to the length of its base, formed a ratio of 1 to 2 pi. If its perimeter is divided by its height, the result approximates the circumference of a circle whose radius equals that height. Charles Piazzi Smith, the Astronomer Royal for Scotland, expanded on this observation in 1864, calling the Great Pyramid a stone record of mathematical and astronomical knowledge. Though his conclusions were criticized for numerology, modern surveys confirmed the accuracy of the pi ratio within a fraction of 1%. What this implies is not coincidence. To embed pi into architecture requires both geometry and an understanding of circular measurement concepts not formally expressed in surviving Egyptian texts. Yet the ratio appears consistently in Giza's design. The second pyramid mirrors the same proportional relationship, while the third, smaller one, preserves it in altered scale. These repeating harmonies suggest that the builders followed a geometric canon older than any written language found nearby. A century later, in 1978, mathematician Livio Stecchini revisited these calculations. He found that the pyramid's dimensions also encode the ratio of Earth's polar radius to its circumference within a margin of 0.1%. The Great Pyramid, he proposed, was a geodetic model of the planet itself. The distance between its corners, if multiplied by a fixed constant, yields an approximate measure of 1 degree of Earth's latitude. This would require knowledge of the planet's curvature, a realization only confirmed by Greek science more than 2 millennia later. Further anomalies appear in the site layout. The distance between the Great Pyramid and the Sphinx equals precisely 1-10th of a degree of Earth's circumference when scaled. The placement of the three pyramids forms an angular offset identical to the offset between the three stars of Orion's belt. The probability of these correspondences being random is vanishingly small. Each structure appears part of a unified blueprint that treats the planet as both map and measure. French architect Jean-Pierre Houdin, while studying the internal passages of the Great Pyramid in the early 2000s, discovered that its inner ramps follow a perfect golden ratio spiral when plotted vertically. The pattern 1.618:1 governs not only aesthetics but natural growth, from shells to galaxies. The same proportion governs the design of later Egyptian temples such as Luxor and Karnak, suggesting that the principle endured for thousands of years. Its earliest expression, however, is at Giza, implying that the builders inherited it from a still older mathematical tradition. When ground-penetrating radar scans of the plateau were analyzed in 2017, researchers found that the foundations beneath the pyramids aligned along a massive grid of 90-degree intersections. These subsurface lines extend beyond the visible monuments, stretching towards Saqqara and Abu Sur. They form a coherent coordinate system, as if the entire region had been surveyed and marked before construction began. Archaeologist Mark Lehner described it as a landscape designed as a single organism. No evidence of such unified planning appears again until much later civilizations. Inside the Great Pyramid's King's Chamber, the blocks are arranged in dimensions that reflect the harmonic ratios of sound. Acoustical testing by the Acoustics Institute of Paris in 1999 revealed that the chamber resonates precisely at 440 Hz, the same frequency used in modern musical tuning. The wavelengths correspond to the chamber's height and width, suggesting the builders understood resonance not as an accident, but as intention. Some theorists suggest this was used to test structural stability, others that it reflects an ancient awareness of sound's physical power. Whatever its function, it points to design guided by unseen mathematics. The hieroglyphs of later Egypt attribute geometry to Thoth, the divine scribe. In the Emerald Tablets, a text of uncertain age, Thoth speaks of the measure of the earth set by the builders before the kings. Whether allegory or memory, it preserves an echo of those who surveyed Giza before writing existed. The geometry they left behind would influence temple orientation for centuries, yet the origin of their measure remains without source. Archaeologists examining quarry marks at Tura, where casing stones were cut, found sequences of numbers and alignment lines that match the slope ratios of the pyramids. These markings are unique. No similar system appears at later sites. Their precision suggests the use of a standardized unit of length slightly shorter than the royal cubit. The Giza cubit, as it is sometimes called, measures 20.62 inches, distinct from the later 20.64-inch royal cubit of dynastic Egypt. The difference seems small, yet across a pyramid's height it changes alignment by several inches. This older cubit's existence hints at a pre-dynastic standard maintained across centuries before Khufu's reign. Beyond Egypt, echoes of similar geometry appear in other megalithic sites. The ratio between Giza's base and height reappears in the dimensions of Teotihuacan's Pyramid of the Sun in Mexico, though separated by oceans and millennia. Both align within a fraction of a degree to true north. Some historians dismiss the connection as coincidence. Others note that both share astronomical orientations to the Pleiades and Orion II star groups visible worldwide during the same epoch around 10,500 BCE. If not communication, then perhaps memory, a pattern carried through time. Mathematical symmetries also link Giza to the Nile itself. The length of the river, from its source to the Mediterranean, equals nearly the perimeter of a circle whose diameter matches the distance between Giza and the ancient city of Heliopolis, both sacred to the sun god Ra. Such geographic harmony suggests that early surveyors viewed land as geometry divine order reflected in the earth's contours. While Egypt's dynastic records name architects like Hemiunu, none mention those who first traced the plateau's lines. Yet even Hemiunu's tomb reliefs show him holding an instrument unknown in other depictions, a straight rod with a looped end, unlike the traditional plumb line. Scholars call it symbolic, but its precise design resembles early surveying devices later rediscovered in Mesopotamia. Perhaps the tool was not symbolic at all, but functional, a descendant of instruments once used by those who measured both heaven and earth. In the stillness of the desert, Giza remains more than stone. It is a map of ratios, of sound and light, of forgotten mathematics, whispered through symmetry. Beneath the dust, the plateau holds its blueprints not on papyrus or clay, but in the eternal geometry of its own construction, silent testimony to a science that existed before recorded time. The lost engineers of stone, when the afternoon sun lowers over Giza, its light slides across the blocks like water. Every ridge, every edge, catches the glare differently. In that glare, the questions return: how, with copper chisels and pounding stones, could such perfection have been achieved? The marks left on the bedrock are quiet but persistent. They whisper of methods that no known tool of the Old Kingdom could produce. In the 1,880 seconds, British engineer Flinders Petrie noticed curious circular grooves cut into fragments of diorite and granite found near the Great Pyramid. The striations spiraled evenly, as though carved by a machine rotating under pressure. Petrie, familiar with industrial engineering, wrote that these grooves resembled the feed marks of a modern lathe. The depth of each spiral suggested a feed rate far beyond that possible with hand tools. Copper, the hardest metal officially available to the pyramid builders, could not have penetrated diorite, one of the hardest stones known. Petrie concluded that the ancient artisans had achieved a technique as yet unexplained by ordinary means. Decades later, engineer Christopher Dunn re-examined those same fragments stored in the Cairo Museum. Under microscopic analysis, he found perfectly spaced tool lines, each uniform to within thousandths of an inch. Dunn proposed that these artifacts may have been cut using a form of mechanical drilling, possibly employing vibration or sonic energy. Though mainstream archaeology dismisses the idea, the marks remain physical evidence, measurable and unchanged. The diorite bowls of Saqqara add another layer of mystery. Found in tombs attributed to the First Dynasty, around 3000 BCE, their symmetry surpasses anything made by hand. Some have walls thinner than a coin, balanced evenly on central axes, as though spun. When laser scans were taken by engineers in the 1,990 seconds, deviations from perfect circularity measured less than a single millimeter. The bowl's internal curves form continuous parabolic surfaces, something achievable only through rotary motion or advanced template guidance. No chisel marks, no layering, just smooth precision in a material harder than quartz. At Giza, large blocks of granite used in the king's chamber show, joint gaps so tight that a razor blade cannot fit between them. Each block weighs over 50 tons. Their surfaces are flat to within 1/100th of an inch accuracy rarely achieved even in modern construction. When these blocks were examined under raking light, they revealed polished planes with directional lines consistent with mechanical abrasion. The question is not simply how they were cut, but how they were lifted and positioned with such exactness deep within the pyramid's interior. Archaeologists propose the use of ramps, sledges, and ropes, but no traces of ramps of sufficient scale have ever been found, and calculations show that the frictional force required would exceed the tensile strength of the ropes known to have existed. Some engineers suggest that the builders may have exploited buoyancy. Chambers beneath the plateau, filled seasonally by Nile floodwater, could have been used as hydraulic lifts, raising massive stones through controlled displacement. The discovery of subterranean water channels and sealed cavities supports the possibility that Giza's builders understood principles of fluid mechanics long before Archimedes described them. In 1979, Japanese researchers attempted to replicate pyramid construction using traditional methods. Their team of 100 men could not move a 2.5-ton block up a 15-degree incline without modern machinery. After several failures, they used cranes to complete the task. Even then, the alignment deviated by several inches. The experiment, intended to demonstrate the feasibility of ancient techniques, quietly illustrated their limitations instead. The Aswan quarries, source of much of Giza's granite, display further clues. A massive unfinished obelisk lies half-carved from bedrock, its sides marked by long parallel trenches. The walls of these trenches are smooth, not chipped. Their curvature implies a tool that removed material evenly, perhaps by grinding rather than chiseling. Some grooves descend in arcs, suggesting circular cutting instruments. Geologists examining the site noted patterns similar to those produced by modern rotary saws. Copper, even hardened with arsenic, would have deformed under such use. Yet the work was abandoned suddenly, as if the tool or method had failed or been lost. Throughout Egypt, isolated fragments repeat this enigma. A basalt slab at the Serapeum of Saqqara bears drill holes perfectly cylindrical, with spiral cores still attached. In Luxor's temple complex, granite columns show lathe-like symmetry. In the Cairo Museum, a fragment of stone identified as core #7 preserves concentric grooves identical to those described by Petrie over a century ago. Each artifact repeats the same story: precision machining in a civilization officially limited to hand tools. In 2013, scanning electron microscopy was applied to residue found inside one of these holes. The analysis revealed traces of silicon dioxide fused to copper particles, a compound formed under high frictional heat. This points not to manual drilling, but to a process involving rapid rotary motion, friction, and temperature sufficient to fuse materials. How such energy was generated remains unknown. Ancient texts offer cryptic hints. The pyramid texts refer to the sound that split the stone, used by the gods in construction. Later, Greek writers like Diodorus Siculus described Egyptian priests manipulating vibrations to move temple stones. Legends of singing stones appear throughout North Africa, though reduced to myth. Modern experiments have shown that sound at specific frequencies can move sand, water, and small objects through resonance. Whether coincidence or memory, these stories persist in a land whose monuments seem to respond to sound even now. The lost engineers of Giza left no written record of their tools. Their legacy survives only in geometry, symmetry, and the impossible polish of diorite. The evidence stands silent under layers of history, eroded by time, but still exact in measure. Every groove and line is a fingerprint, one belonging not to chance, but to a method that has vanished. Whatever force shaped these stones, it worked with precision, patience, and understanding deeper than the desert's silence. Echoes beneath the plateau. When night falls over Giza, the desert cools and the stone exhales. The wind that crosses the plateau carries faint sounds that seemed to come from the ground itself, low, hollow, and rhythmic, like water inside a vessel. For centuries, locals spoke of chambers beneath the sand, tunnels connecting the pyramids, and sealed halls that no living person had entered. Modern science, armed with seismic sensors and radar, began listening. What it heard was more than myth. In 1993, a Japanese team from Waseda University conducted seismic tomography beneath the Sphinx. The readings came back irregular. They showed cavities beneath the monument, one under the left paw, another running diagonally toward the Great Pyramid. The anomalies were rectangular in shape, with sharp boundaries that did not match natural fissures. The data suggested something hollow, with vertical walls and flat ceilings. It was the first scientific confirmation of voids beneath Giza. Egyptian archaeologist Zahi Hawass publicly dismissed the findings as errors in interpretation. But in his private notes, later leaked to the press, he acknowledged the existence of cavities and unexplored chambers. Access was soon restricted. The Egyptian Antiquities Department sealed the area to further foreign excavation, citing the need to prevent misrepresentation. Earlier evidence had already hinted at what lay below. In 1925, workers clearing debris south of the Great Pyramid discovered a deep vertical shaft lined with limestone blocks. At its base was a chamber flooded with still water. They called it Campbell's Tomb. It extended 30 meters below the surface. Inside were fragments of stone sarcophagi and traces of black resin. The walls bore no inscriptions. Scholars labeled it a subsidiary burial, but the design was unlike any known tomb of the 4th dynasty. It seemed older, more primitive, yet more deliberate. In 1933, Émile Barrès, during his restoration of the Sphinx, found an entrance cut into the creature's north flank. The passage descended steeply before turning toward the east. After exploring several meters, the team encountered a collapse and stopped. The excavation records, written in French, mention cool air and hollow resonance ahead. The tunnel was later resealed with concrete. During the 1,970 seconds, engineer Thomas de Beckie and geologist Robert Schoch, better known for their work on Sphinx erosion, conducted seismic surveys on the plateau's western edge. Their instruments detected what appeared to be a large cavity 25 meters below the surface, near the so-called Osiris shaft. When the site was finally excavated in the late 1,990 seconds, it revealed 3 descending levels connected by narrow shafts. At the lowest level lay a central island, surrounded by water and 4 stone pillars. Archaeologists found no human remains. Only an empty granite sarcophagus rested in the middle. The structure was unlike any known Egyptian tomb. The walls were undecorated. The architecture was stark, functional, and precise. Water continually seeped in from the surrounding rock. The chamber's acoustic qualities were extraordinary voices carried in perfect echo. Some researchers suggested that it served not as a burial, but as a ritual sound chamber, perhaps for ceremonies connected to the underworld god Osiris. Yet radiocarbon testing of organic residue from the walls suggested construction long before the Old Kingdom, possibly during the pre-dynastic era. Ground-penetrating radar studies in 2015 by the Scan Pyramids project expanded the mystery further. Instruments placed along the Sphinx causeway and near the Great Pyramid revealed multiple low-density zones voids consistent with tunnels. One extended beneath the plateau's surface toward the Valley Temple. Another appeared to curve beneath the Sphinx itself, connecting to the area beneath its western flank. These results mirrored descriptions recorded by Arab chroniclers 1,000 years earlier. In the 13th century, historian Abd al-Latif al-Baghdadi wrote of passages under the pyramids, filled with strange writings and sealed doors. 2 centuries later, al-Makrizi described a house of records beneath the Sphinx, said to contain ancient tablets from before the flood. The idea endured through generations, retold in Greek and Coptic versions as the Hall of Records. Though dismissed as legend, the consistent detail, a hidden library buried below the lion-bodied monument, suggests that the story may preserve an older memory of the plateau's real substructure. In 1998, Joseph Shaw's American research team, working with the Edgar Cayce Foundation, received limited permission to conduct non-invasive scans near the Sphinx. Their radar data confirmed an anomaly, an empty space directly beneath the left paw, roughly rectangular and 12 meters long. They described its shape as architectural. The data were never released publicly in full. Shortly afterward, access to the area was withdrawn, and the project quietly ended. The Egyptian authorities maintain that all cavities are natural. Yet every year, new anomalies appear on surveys. A 2021 electrical resistivity study by Cairo University identified several unexplained voids between the Great Pyramid and the Sphinx Causeway, some over 20 meters wide. Their outlines correspond to no known construction shafts or quarries. They remain sealed beneath untouched sand. Ancient writings from the Book of the Dead speak of the caverns of Sokar beneath the House of the Horizon. In these texts, the soul travels through underground halls guarded by gates of iron. Whether metaphor or memory, such imagery aligns with the plateau's unseen architecture. The Sphinx, in this sense, may be more than a monument, it may be a marker of entrance, placed above what the ancients called the mouth of the earth. Hydrological studies reveal that the plateau rests atop a network of limestone channels saturated by groundwater. During heavy Nile floods in antiquity, these channels would have filled, producing sounds of resonance beneath the ground. The ancient Egyptians called such vibrations the breath of the underworld. Modern geophysicists record them as low-frequency seismic waves, still detectable today. The desert, quite literally, hums beneath the stone. Whether these chambers hold artifacts, records, or nothing but air, their presence affirms one truth: the Giza Plateau was shaped both above and below. The monuments we see may stand on the surface of a far larger structure, a city of voids, corridors, and caverns sealed in time. The echoes continue beneath the sand, vibrating faintly through the stone, waiting for the silence of thousands of years to end. When the sky aligned with stone, at dawn, the first light over Giza does not strike the pyramids at random. It creeps along an invisible pattern, touching stone edges that once mirrored the heavens themselves. The plateau's alignment to the stars is too exact to be coincidence. Every block, every causeway, seems to echo a sky that no longer exists, a map of the firmament as it appeared over 12,000 years ago. The idea was first noticed by the engineer and Egyptologist Alexander Badai in the 1950 seconds. He observed that the main axis of the Great Pyramid pointed almost perfectly to true north, deviating by only 3 arc minutes. That level of precision would be difficult even with modern instruments. Later, astronomer Virginia Trimble recalculated that the original alignment would have been exact if measured during a period around 10,500 BCE. It was as if the builders had oriented their monuments not to the sky above them, but to a sky remembered. In 1983, Robert Bauval began comparing the arrangement of the 3 Giza pyramids to the stars of Orion's belt, Alnitak, Alnilam, and Mintaka. He noticed that the offset of the smallest pyramid matched precisely the displacement of Mintaka from the other 2 stars. When the positions were plotted using astronomical software, the match became perfect only when the star map was set to the night sky of 10,450 BCE. During that epoch, Orion's belt lay directly above the horizon where the Sphinx faced east. If this alignment was intentional, it meant the Giza complex formed a terrestrial reflection of Orion. The pyramids became the stars. The Nile mirrored the Milky Way. The entire landscape functioned as a cosmic diagram, a model of heaven built in stone. Egypt's oldest texts support this interpretation. The pyramid texts describe the pharaoh's soul ascending to Orion to join Osiris, the god of resurrection. He goes to the sky among the stars of Orion, reads one passage from Unis's tomb, dated to 2300 BCE. The alignment may have been both symbolic and astronomical, linking the king's afterlife to the path of the stars. The Sphinx, facing due east, aligns not with Orion but with Leo. During the same epoch of 10,500 BCE, the constellation Leo rose directly before the Sphinx's gaze at the spring equinox. The monument's body, a lion, mirrors the shape of that constellation. The combination suggests deliberate design. Orion and Leo, Osiris and the sun, balanced across heaven and earth. The alignment ties Giza's builders to an era when the Earth's axial tilt placed these constellations in positions now lost to time. Precession, the slow wobble of Earth's axis, shifts the positions of stars over millennia. To design structures aligned to constellations at a specific precessional point requires advanced astronomical knowledge. The rate of precession was not calculated by modern science until Hipparchus, around 130 BCE. Yet whoever laid out Giza's geometry seems to have accounted for it more than 10,000 years earlier. In 1994, Belgian engineer Luc Gabolde analyzed the internal shafts of the Great Pyramid using laser theodolites. He found that the southern shaft of the King's Chamber pointed toward Orion's belt, while the northern shaft aligned with the circumpolar star Thuban, then the pole star of 2500 BCE. Meanwhile, the Queen's chamber shafts targeted Sirius and Kochab. These alignments were not random ventilation passages. They were fixed sightlines to specific stars, marking both the celestial and terrestrial order. The pyramid's slope of 51 degrees and 51 minutes reflects the same angle as the tangent of the circle divided by 2 pi, but it also corresponds to the elevation of Orion's belt above the horizon at Giza around the epoch of 10,450 BCE. The builders may have encoded this astronomical snapshot into the very shape of the pyramid, preserving the heavens as they once were, long before the time of the pharaohs. Astronomer Thomas Brophy expanded the theory using ground and star mapping. He discovered that small stone circles west of Abu Sur correspond to the positions of the stars in Orion's belt across precessional ages, with each circle marking a star's movement through the sky over thousands of years. If correct, these circles form an astronomical record spanning 12 millennia. It would mean that whoever began the mapping of Orion continued it across epochs, perhaps rebuilding in memory of an original plan. Even the Great Pyramid's entrance passage tells a story of time. It points toward the northern sky at an angle of 26 degrees. Around 2500 BCE, this view aligned with Thuban. But set backward in time to 10,500 BCE, it aligns with Vega, one of the brightest stars of the ancient sky. The monument's builders may have locked 2 ages of precession into their design, one marking their present, the other preserving their origin. Other monuments echo the same celestial scheme. At Heliopolis, the obelisks stood in pairs, symbolizing the sun's rays. Their shadow lines at noon pointed toward Giza's apex. In the ancient city of Abydos, the Osirians' underground chambers are aligned to the rising of Orion, not the sun, suggesting a tradition older than solar worship. Together, they form a chain of stone observatories stretching across the Nile Valley. Myth and measurement converge in the same silence. The Egyptians spoke of Zep-Tepi the first time, an age when gods ruled on earth and established the order of heaven and stone. The astronomical precision of Giza may be a physical record of that memory. Every alignment, every shaft seems to reach backward into a forgotten epoch when the sky and ground were one system. Modern astronomy confirms that the positions of Orion, Leo, and Sirius during 10,500 BCE match the layout of Giza and its surrounding temples exactly. Since then, precession has shifted the stars by nearly 36 degrees, yet the monuments remain fixed, eternal markers of a vanished sky. Each night, as Orion rises once more over the horizon, the pyramids stand as if remembering. Their edges catch the starlight, exactly where ancient surveyors once traced them. The heavens have moved, but the plan beneath them has not. Giza, frozen in geometry, preserves a memory of the stars as they were in a time before history when sky and stone still spoke the same language. The memory of the flood. Long before sand buried the plateau, water ruled it. Beneath Giza's dust lies the memory of a world undone by storms, a continent reshaped by sudden melting, violent rains, and the slow drowning of plains that had once been fertile. The monuments, when viewed against this deeper backdrop, seem less like beginnings and more like memorials, stone witnesses to an event the ancient world never forgot. Around 12,800 BCE, at the close of the Pleistocene, Earth entered a brief but devastating reversal, known as the Younger Dryas. Ice sheets that had begun to recede suddenly returned. The climate shifted in a single generation. Geological cores, taken from the Nile Delta and eastern Mediterranean, show abrupt layers of flood deposits dating precisely to this period, fine silt over compacted clay, mixed with microfossils from both river and sea. It was a time when coastlines vanished and rainfall patterns changed so drastically that northern Africa's deserts briefly bloomed, then hardened again into stone. Robert Schoch, whose weathering studies of the Sphinx challenged its accepted age, found that the monument's enclosure walls carried deep vertical fissures typical of sustained rainfall erosion, yet Egypt has been arid since about 3000 BCE. For such patterns to exist, the Sphinx must have endured heavy precipitation during the wetter epoch following the last ice age. The same signature appears on the bedrock beneath the Great Pyramid, a smoothing consistent with long-term water exposure, later sealed under new construction. The plateau may once have overlooked a green floodplain dotted with pools, not a desert. Far from Egypt, myths of that same catastrophe repeat with uncanny precision. The Sumerians spoke of a deluge sent by the gods to erase mankind. The Hebrews recorded Noah's flood. The Greeks remembered Deucalion and Pyrrha. Even in remote Andean traditions, a great inundation marked the boundary between the ages of the world. The flood myth appears global because its memory is geological. Between 10,000 and 9,000 BCE, sea levels rose by more than 100 meters as ice sheets collapsed into the oceans. Entire regions, Doggerland in Europe, Sunderland in Asia, and the vast plains north of Africa disappeared beneath the waves. Along Egypt's Mediterranean coast, sonar surveys by French and Egyptian teams in 2001 revealed submerged structures near Alexandria walls and column bases buried under silt, some with inscriptions predating the Ptolemaic era by millennia. The Nile Delta's seabed holds even older river channels now drowned far offshore. These Paleo-Nile tributaries suggest that before the floodwaters stabilized, the river's mouth lay hundreds of kilometers north of its present course. The civilization that once lived near its banks may have watched its homeland sink, retreating southward toward what became Giza. Geologists from Cairo University have documented thick deposits of fine gravel and rounded pebbles around the base of the Sphinx temple material, typically laid down by flowing water, not desert wind. The sediment fills channels cut into bedrock, indicating that torrents once raced across the plateau. To the ancient mind, such destruction would not have been mere weather, but cosmic correction. Later, Egyptian texts speak of a great inundation when the god Atum rose from the floodwaters to remake the world. The Sphinx, half buried yet enduring, may have been carved in remembrance of that rebirth. The flood's reach extended beyond Egypt. In 1997, oceanographer William Ryan and geologist Walter Pittman analyzed sediment cores from the Black Sea. They found evidence that around 5,600 BCE, the Mediterranean breached the Bosporus, flooding the basin in a single catastrophic event. Though later than the Younger Dryas, it marks a chain of post-glacial disasters that would have echoed through oral memory. People displaced by rising seas may have carried their myths inland to Mesopotamia, to Anatolia, to the Nile. Giza's earliest engineers could have been heirs to survivors who remembered both land and loss. Satellite imagery reveals patterns in the desert west of Giza, ancient riverbeds now dry, curving toward the plateau like veins leading to a heart. When these were mapped, geologists identified at least 3 extinct tributaries. Their presence explains the groundwater channels still active beneath the pyramids today. If the plateau was once an island in a marshy basin, its builders may have chosen it for its high ground, above the chaos of the floodplain. The great monuments would thus mark not only spiritual ascent, but physical survival. Evidence of reoccupation after flooding appears throughout pre-dynastic Egypt. At Nabta Playa, deep in the Nubian desert, archaeologists found a stone circle aligned to the summer solstice, dated to around 7000 BCE. Nearby, pottery fragments display aquatic motifs, fish, waves, and reeds. The site lies in what is now arid wasteland, yet sediment beneath it shows that it once held a permanent lake. When the rains ended, its people migrated north, perhaps bringing their astronomical and architectural knowledge to the Nile Valley. In this timeline, Giza becomes not the origin, but the continuation of a tradition born in the aftermath of climate collapse. Even in myth, echoes of the flood remain coded in geometry. The pyramid's slope angle, 51 degrees and 51 minutes, mirrors the latitude where the Earth's circumference equals its height ratio, a proportion that symbolizes balance between chaos and order. The base's orientation to true north, unerring despite millennia of shifting sands, could represent stability after catastrophe, a fixed point for a world once overturned by water. At the heart of the Osiris cult lay this same duality, death and rebirth, submersion and rising again. Osiris was said to have been drowned and dismembered, his body scattered through the Nile. Isis gathered the pieces and restored him, giving rise to the first resurrection. Beneath myth lies a reflection of geological truth, the land itself drowned and reborn. Each annual Nile flood reenacted that memory, turning destruction into renewal. Archaeological records show that as Egypt's climate dried around 5000 BCE, settlements shifted permanently to the Nile's banks. The flood, once real, became ritual. Temples rose where the waters reached their highest mark each year, turning geology into ceremony. By the time Khufu's builders shaped the Great Pyramid, the event had already become legend, a story told by priests who measured time not in centuries, but in inundations. Yet the stones still bear the older language, erosion lines, silt pockets, and shells trapped in limestone joints. They record the same story written in myth, the world changed by water. Beneath Giza's monuments, the memory of the flood remains, silent but measurable, echoing through the ages as the first catastrophe humanity ever tried to outlast by turning memory into stone. The survivors of the first time, when the floods retreated, they left more than mud and silence. They left survivors small groups scattered across what had once been coastlines and fertile valleys, carrying fragments of memory that would later be called myth. From these remnants, civilizations slowly rekindled. The Egyptians would name their forgotten ancestors Netjeru, the divine beings of the Zep Tepi, or first time. Whether gods or men, they were said to have rebuilt the world after the waters fell, Archaeological traces of these earliest settlers stretch across Egypt's deserts, forming faint paths between what were once lakes and green basins. At Nabta Playa, 700 kilometers south of Giza, an ancient settlement lay buried beneath the dunes. Excavations by Fred Wendorf and Romuald Child in the 1972 revealed stone circles, ceremonial walkways, and megaliths aligned with the rising of Orion's belt and the summer solstice. Radiocarbon dates place the site between 7,500 and 6,000 BCE, thousands of years before Egypt's first recorded dynasty. The same celestial motifs that would later define Giza had already been mapped in stone by herders living in what is now desert. These people were not primitive wanderers. Their tools were polished, their pottery decorated with geometric patterns, their huts arranged in deliberate orientation to the stars. At the center of Nabta Playa stood a stone platform thought to have served ritual purposes, its design echoing the earliest temples along the Nile. Scholars believe its builders were pastoralists, following seasonal rains, yet their mastery of astronomy suggests a deeper continuity, a retained science, inherited from those who had lived through the great climate upheaval. Farther north, near Chena, sites such as El Badari and Hierakonpolis preserve the bones of transition. Excavated graves show evidence of social hierarchy, carved ivory combs, copper beads, and figures carved from basalt and schist materials, difficult to shape without advanced tools. The imagery on Bedouin artifacts features reed boats with tall, curved prows, sailing not along the Nile, but across open water. Some depictions show celestial discs overhead, as if charting journeys guided by stars. These motifs hint that the ancestors of Egypt's founders were not bound to the river, but came from beyond it, perhaps following coastlines lost to the rising seas after the Younger Dryas floods. The earliest hieroglyphic symbols may preserve their memory. On ivory tablets found at Abydos, dating to 3,300 BCE, appear signs that have no known linguistic root. One resembles a three-tiered pyramid. Another depicts a circle split by waves, an image interpreted as island or sun over water. These symbols fade in later periods, replaced by standardized script. It is as though the earliest scribes wrote in a language of survivors, half myth, half record, describing where they came from before the first kings united the Nile. Across the Near East, other fragments mirror this pattern. In southeastern Anatolia, at Göbekli Tepe, megalithic enclosures dating to around 9,500 BCE rise from limestone hills. Their T-shaped pillars bear carvings of animals and celestial symbols. The site predates agriculture, metal, and writing, yet displays architectural sophistication equal to any temple. Archaeologist Klaus Schmidt noted that its builders buried the entire complex deliberately, preserving it under earth for unknown reason. The orientation of its enclosures, particularly enclosure D, aligns with Sirius, just as the Queen's chamber shafts of the Great Pyramid do. The resemblance is not proof of contact, but it is a whisper of memory, a shared vision stretching back to an epoch when sky and earth were one map. The Nile may have served as the migration path for these bearers of knowledge. As North Africa dried, groups from the Sahara drifted toward the valley's remaining water. Petroglyphs in the Gilf Kabir Plateau showed giraffes, fish, and boats carved when the region was still green. One famous image, the swimmer's panel, depicts human figures floating in curving lines, perhaps recalling the inundation. The art fades abruptly around 5000 BCE, coinciding with desertification. By then, most of the population had moved eastward toward the river, bringing with them the astronomical and architectural traditions that would culminate at Giza. The term Shemsu-Hor, the followers of Horus, appears in later king lists as rulers before Menes, Egypt's first pharaoh. Manetho's 3rd century BCE chronology records their reigns as stretching back thousands of years before the dynasties began. Some texts call them servants of the light, others the restored ones. To later Egyptians, they were mythic figures. To modern historians, they may represent the line of pre-dynastic chieftains whose memory was preserved as divine kingship. Yet their sudden disappearance from the record suggests a veil drawn between two epochs, the mythic world of survivors and the historical world of pharaohs. In 1898, British archaeologist Flinders Petrie excavated the tombs of these so-called proto-dynastic elites at Abydos. He found not crude graves, but chambers of finely cut stone, sealed with mortared brick, containing vessels of diorite and obsidian materials foreign to Egypt's geology. Some of the artifacts match styles later seen at Giza. Petrie remarked that the early culture seems intrusive, as though brought complete from elsewhere. No source was ever identified. Myth offers a direction, if not a destination. In the Book of the Dead, the deceased declares, "I am he who came forth from the flood, who crossed the waters of chaos." This phrase, repeated across coffins and temple walls, echoes the memory of survival. To be reborn was to repeat what humanity had once achieved. Emergence from the deluge into ordered life. The priests who guarded these rituals saw themselves as keepers of knowledge inherited, not invented. By the time Khufu's architects raised the Great Pyramid, those who carried the last fragments of the Zep Tepi were long gone. Yet their geometry, their astronomy, and their myths remained embedded in the land. The survivors of the first time may never be named, but their fingerprints lie in every alignment, every ratio, every silent chamber beneath the plateau. They built not for glory, but for continuity, to ensure that even if memory drowned again, the measure of what was lost would endure in stone. The language of stone, every monument at Giza speaks, though not in words. The messages were carved through geometry, vibration, and the play of sunlight over polished stone. The builders, whoever they were, seem to have understood that stone could store, meaning the way papyrus stores ink. Their language was form itself, a code that used proportion, resonance, and shadow to communicate ideas that words could not contain. When the Great Pyramid was first completed, it shone like a mirror. Its casing of white Tura limestone reflected the sun so brightly that ancient travelers called it Ichet, the glorious light. The pyramid's proportions obey the constant of pi and the golden ratio phi, numbers that reappear throughout the plateau's structures. To the Egyptians, these were not abstractions, but symbols of balance, the union between the infinite and the measurable. Through them, stone became mathematics turned sacred. Inside the Great Pyramid, the geometry continues in silence. The Grand Gallery rises at an angle of precisely 26 degrees, its walls narrowing toward a vanishing point far above. Acousticians have recorded standing wave frequencies along its length. Each clap of sound ricochets in harmonic intervals, forming resonances at 440 and 880 Hz, the same double octave known to modern music. The space behaves as a giant resonator, tuned to vibration. Ancient texts called the pyramid the house of energy, and while that phrase may have held spiritual meaning, its physical truth still hums faintly between the granite walls. The king's chamber itself, built entirely of Aswan granite, amplifies low frequencies like the body of a stringed instrument. Engineers measuring its response to sound found that it vibrates naturally when struck, its four walls and ceiling forming a harmonic cavity. In this chamber, even a whisper lingers longer than it should. Whether deliberate or not, the precision of its dimensions transforms still air into music. At certain times of year, sunlight enters the pyramid's internal passages at exact angles. During the summer solstice, the light of dawn strikes directly through the descending corridor. On the winter solstice, the setting sun aligns with the opposite passage. These shafts form a calendar written in light, a silent record of celestial cycles, encoded within the structure. The builders used illumination itself as syntax. The temple complexes surrounding the pyramids continue this geometric language. Each hall is a progression of ratios. One room squares the preceding chamber, another halves its dimensions. This rhythm of expansion and contraction mirrors the oscillation of breath or heartbeat. Walking through these spaces, one moves through measured harmonies. The architecture does not describe the divine, it imitates it. Hieroglyphic texts later explain this principle through the concept of marked cosmic order maintained through precision and truth. The same word governed both moral law and architectural alignment. To build was to restore harmony between heaven and earth. Every angle, every vibration was part of an invisible grammar that connected stone to star. At the Temple of Hathor in Dendera, ceiling carvings depict a series of stars and waveforms radiating from central figures. Some researchers interpret them as symbolic depictions of sound or light vibration as the essence of creation. The Egyptian term for to speak and to make shared the same root, implying that sound itself was the act of forming. This may explain why sacred names were written, but rarely spoken. Their power belonged to resonance, not pronunciation. In 2018, French and Egyptian scientists used muon radiography to scan the Great Pyramid. They discovered an unknown void 30 meters long above the Grand Gallery. Its purpose remains uncertain. Yet its placement corresponds to the harmonic node between two resonant frequencies of the structure. Some physicists now speculate that it serves as a structural or acoustic stabilizer, a chamber not for burial, but for balance. Even after 4,000 years, the pyramid continues to answer sound with structure. Beyond resonance, light was another alphabet. In the Temple of Abu Simbel, built later yet following the same principle, the inner sanctum receives sunlight only twice a year on the birth and coronation days of Ramses II. At Giza, similar alignments likely existed before erosion and time shifted their accuracy. The architects treated the sun as punctuation, marking the rhythm of the year with lines of gold cast into stone corridors. Mathematics, too, was woven into their syntax. The Great Pyramid's perimeter divided by twice its height equals 3.1416, the value of pi accurate to 4 decimals. Its height to base ratio matches the square root of 3, the geometry of equilateral triangles. The distances between Giza's monuments form geometric progressions consistent with Pythagorean theorems millennia before Pythagoras was born. Numbers were not decoration, they were vocabulary. The Shabaka stone, an inscription from the 25th dynasty, describes how creation began when the god Pa thought in his heart and spoke with his tongue. To think was geometry, to speak was vibration. The cosmos was built through the same dual process that shaped the pyramids thought made visible, sound made solid. The language of stone was therefore not metaphorical, but literal, the translation of vibration into architecture. Every visitor to Giza still feels this unspoken dialogue. The scale quiets the mind, the angles draw the eyes upward, the silence inside the chambers vibrates in the chest. It is a communication older than words pattern recognized by the body. The builders carved intention into the physical world so that even when their language was forgotten, their meaning could still be felt. In the long span of history, paper burns and speech fades, but proportion endures. A pyramid cannot be misread. Its lines remain the same under every sun. It speaks through mathematics, light, and resonance, a message that no translation can distort, reminding us that once, long ago, knowledge was carved not in books, but in the very bones of the earth. The vault of hidden knowledge, beneath the unbroken silence of the Giza Plateau, whispers of an unseen library have persisted for thousands of years. The ancients called it the House of Thoth. Later mystics named it the Hall of Records. It was said to contain the wisdom of the first time the age before Egypt, when gods and men shared the same language of creation. Whether legend or memory, this idea of hidden archives buried under stone has remained one of Giza's most enduring mysteries. The earliest known reference appears not in Egyptian scripture, but in Plato's Timaeus, written around 360 BCE. He recounts Solon's visit to Egypt, where priests at Sais told him, "There have been many destructions of mankind, and your Greeks are but children." They spoke of records preserved through floods and fires, stored in their temples since the dawn of civilization. Solon's story inspired Plato's tale of Atlantis, but it also introduced the concept that Egypt was the keeper of knowledge from a world that came before. Later, Greek writers repeated the theme. Strabo described underground passages beneath Memphis and Heliopolis, where sacred scrolls were kept safe from invasion. Diodorus Siculus wrote that priests of Thebes preserved astronomical data from times when the stars themselves were in other places. These accounts, though fragmentary, form a chain of testimony pointing to the belief that the land of the Nile held records older than history itself. The Egyptian sources are more cryptic. The Book of the Dead and the Pyramid texts speak of chambers of the nether sky and halls of archives beneath the house of the horizon. The god Thoth, scribe of the gods, inventor of writing, was said to guard these records, granting fragments of them to the worthy. In the Shabaka stone, a priest king claims to have copied ancient writings found worm-eaten from the time of the ancestors. Whether literal or symbolic, it reflects a pattern of rediscovery, a civilization rebuilding itself from fragments of an older source. In 1933, during his restoration of the Sphinx, engineer Émile Barrès unearthed an entrance near the statue's north flank. The tunnel descended sharply and then turned eastward. After proceeding several meters, his crew encountered debris and halted. Barrés's notes, stored in the Cairo archives, mention a second cavity and unusual cool air flowing from below. He believed it led to sealed chambers. The tunnel was later reburied and fenced off. No official explanation was given. Half a century later, in the 1970 seconds and 1980 seconds, seismologist Thomas de Becchi and geologist Robert Schoch detected hollow zones under the Sphinx using seismic refraction equipment. One anomaly, directly beneath the pores, was roughly rectangular, about 9 by 12 meters. Another extended toward the Great Pyramid. The data, never disproven, confirmed what ancient tradition had claimed. Cavities existed under Giza, built or natural, yet unexplored. In 1998, Joseph Shaw and his American research team, sponsored by the Edgar Cayce Foundation, were granted limited access to the area. Cayce, decades earlier, had predicted that a haul of records would one day be discovered between the Sphinx's pores, containing the chronicles of a lost civilization destroyed by flood. Score's team used ground-penetrating radar and confirmed a void of geometric shape directly beneath that location. Before excavation could begin, permits were revoked. The official explanation cited concerns for structural safety. No further investigation followed. Egyptian authorities have since maintained that all underground cavities are natural, yet the data continues to suggest otherwise. In 2017, the Scan Pyramids mission announced the discovery of a massive void above the Grand Gallery of the Great Pyramid, 30 meters long, unexplained by any known construction design. Though officially labeled an anomaly, its precise geometry implies human intent. Its placement corresponds to the pyramid's internal harmonic node, leading some to theorize that it could serve as a repository or balancing chamber deliberately sealed from access. Medieval Arab chroniclers also wrote of secret vaults. Al-Makrizi, in the 15th century, described how King Surid, identified by some as a pre-flood ruler, built the pyramids to preserve the arts and sciences of his age, before a cataclysm of water and fire. He placed treasures and records of wisdom within sealed halls beneath the monuments. The tale, dismissed as myth, mirrors earlier traditions of Atlantean archives hidden under the sands. Yet, like so many legends, it may encode a memory of real preservation efforts during ancient climate upheavals. Recent discoveries in other Egyptian sites lend weight to the idea of deliberate subterranean storage. Beneath the Temple of Dendera, corridors carved with precision spiral under the main complex. At Saqqara, the Serapeum's granite vaults hold massive stone boxes fitted with tolerances too fine for burial alone. These spaces, cut deep into bedrock, show engineering more advanced than surface structures of the same era. They demonstrate that the Egyptians, and perhaps their predecessors, understood how to build chambers intended to last beyond disaster. If a hall of records exists, its contents would not likely be papyrus. Organic material could not survive millennia underground. Instead, the records might be geometric and physical encodings of knowledge through architecture itself. The precise orientation of the pyramids, the mathematical constants embedded in their dimensions, and the celestial alignments could represent data preserved in stone rather than script. In this sense, Giza itself is the archive, a message written in form rather than language, waiting for those who can read its code. The late Egyptologist Chwala de Lubitsch once wrote, "The temple is a book, its proportions are its words." To the builders of Giza, measurement was not utility, it was communication. The vault of hidden knowledge may therefore be less a chamber of scrolls than the total architecture of the plateau, a physical equation describing earth, sky, and time. Today, the desert keeps its silence. Ground scans continue to find empty spaces. Permits continue to close them again. Yet the belief persists that beneath the Sphinx and the pyramids lies something older than Egypt itself, a record not of kings, but of continuity. If these vaults ever open, what they reveal may not be new information, but the realization that the message was visible all along, written in the only language that endures, the geometry of the world itself, the stone that remembers. In the quiet hours before sunrise, the Giza Plateau stands in perfect stillness. The desert air is cold, the stars fade one by one, and the first line of light reaches the peak of the Great Pyramid. For a few moments, the world looks unchanged from how it must have looked thousands of years ago. The stones catch the same dawn. The shadows fall in the same geometry. It is not just a monument, it is memory, solidified. Every civilization builds something to outlast itself. Egypt built permanence. What began as shelter became symbol, then message. Beneath the layers of sand, under the centuries of ritual and conquest, the same principle endures, the act of remembering through structure. Giza is not the story of kings, but of continuity, the attempt to make thought survive erosion. Archaeologists have measured and mapped every surface of the pyramids, yet the deeper pattern remains invisible to ordinary sight. Their precision is not only architectural, it is temporal. Each block fixes a moment, each ratio recalls a sky no longer overhead. The monuments are clocks that do not tick, calendars that do not turn. In their silence, they keep the rhythm of a vanished age. Perhaps this was their purpose to bridge worlds. When the builders raised these structures, they inscribed constants that would remain true even when languages vanished. Pi, Phi, the cardinal directions, the path of Orion, the tilt of the earth. These numbers do not belong to any one culture. They belong to reality itself. Whoever carved them understood that truth survives through form. The desert has buried and revealed this knowledge in cycles. Wind erodes, sand conceals, rediscovery begins anew. Each generation thinks it has uncovered the mystery, but the mystery is not what lies beneath. it is what has endured above. The Great Pyramid has lost its casing stones, its capstone, its names, yet not its measure. Even stripped to its core, it holds perfect alignment. It remembers what the world forgets. When seismic scanners listen to the earth beneath Giza, they hear hollow chambers, spaces that echo when struck. Some call them voids, others vaults, but their sound carries through the rock like a heartbeat. If these chambers were meant to preserve more than bodies, if they were meant to preserve a pattern, then they have succeeded. The builders made a message that cannot decay because it speaks in balance, not language. In the myths, after the flood, the survivors built pillars of wisdom to store all that might be lost again. The Book of Enoch speaks of 2 columns, one of brick for fire, one of stone for water. When the world ended, one would remain. In that myth, knowledge was not written in letters, but in matter itself. Giza could be one of those pillars, the one that endures through deluge and drought, guarding not content, but comprehension. Standing at the base of the Great Pyramid, a person feels scale more than sight. The body measures itself against the weight of time. The limestone blocks, each bearing marks of human hands, rise with a logic that feels both deliberate and detached, as though built by minds that knew they would be forgotten but trusted mathematics to remember them. The plateau holds no inscription naming its architects, no signature, no date. Yet that absence may be its design. Identity fades, understanding remains. To record without author is to speak to all who come after. The builders left us not their names, but their method measurement as memory, harmony, as heritage. From the top of the Great Pyramid, the horizon curves gently. The Nile glints in the distance, the same river that once fed a greener land. The constellations of Orion and Sirius rise differently now, shifted by precession, but their pattern still echoes the arrangement of the stones. The message has lasted across the drift of the heavens. When the last rays of daylight fade, the pyramid returns to shadow, its angles dissolving into the desert's dark. Yet even in darkness, it remains exact. The stars move, the wind changes, dynasties rise and fall, but the geometry does not. It was meant for that, for the long forgetting. Perhaps this is what the ancients called immortality, not life without death, but memory without decay. To stand at Giza is to stand inside that intention, to realize that time itself can be measured, shaped, and remembered. The builders carved a truth that does not need belief, that what is balanced endures, that knowledge aligned with nature cannot be erased. And so, as dawn returns, the stone turns gold again, and the desert breathes out its chill. The Great Pyramid stands as it has for more than 40 centuries, unchanged, unanswering, and utterly alive with silence. The world moves around it, but it remains the axis of memory, the last monument of a world that knew how to make thought eternal. The desert sleeps, but the stones do not. They continue to measure the same stars, to hold the same silence that has lasted for millennia. Whether carved by hands of men or by those we can no longer name, the Great Pyramid still stands as a reminder that history is never complete, only uncovered, one grain of sand at a time. Perhaps the truth of Giza's hidden timeline isn't buried beneath the plateau, but written across it, waiting for us to learn how to read its quiet geometry. If the past leaves questions that echo louder than answers, stay with us. There are more forgotten worlds to unearth, more timelines that stretch beyond the maps we know. Join us again, and together we'll keep tracing the evidence that time could not erase. Subscribe, stay curious, and let the next mystery begin.